the big challenge has been for basically as long as computers have existed to somehow teach computers to understand legal reasoning.
I have to read a lot of text for being a lawyer or being a jurist, and the aim was to enable the computer to read the text for me.
Yes. So you're starting with natural language and you're trying to extract meaning from it.
Yes.
And we're starting with the meaning and
Yes.
we're trying to produce natural language from
Yes.
it.
Welcome to the second edition of the hacking.law podcast. We're again at the hackathon in Berlin, the hacking.law hackathon. And I'm here with Florian, blockchain lawyer, Kristall, developer and jurist, and Meng, who's a computer scientist and founder of the startup Lexys. And before we're going to start, we also have Buzz Lightyear with us and the buzzword buzzer, which is, you're all free to use it. Whenever somebody uses a buzzword, you just buzz it, and then the person needs to describe the buzzword in a very simple way. Okay? And we're going to talk today about a new programming language for law. And Florian, I'd like to start with you. Why do law needs to have a new programming language?
So it has
why does it need to be into the computer, to start with that? Why do we have it?
Exactly, that's the actual question behind this, I would say, and it is that if you allow computers to more deeply understand what is actually being meant to be regulated in a legal contract, then you have a plethora of tools available to you to draw conclusions about what might happen in certain scenarios. In a way, you can harden your contract, which tries to regulate the future in some sense. You can harden it against various edge cases, for example, and you can find mistakes that people usually tend to do when they write long documents of text. And the big challenge has been for basically as long as computers have existed to somehow teach computers to understand legal reasoning and to understand what a text means, not just in terms of the letters that are in it, but what a human reading it would process and understand. And it's one of the toughest challenges out there. Some say it's a hard AI problem, and it's currently unsolved, and it's exciting to see that now in this wave of digitalization, the law is being tackled ultimately now, and people really try to advance in this field of research.
Okay, Kristall, you have been working, or you have developed a software
Yes.
for legal text.
Yeah, not specifically for legal text, but more general for understanding German text.
Okay.
So the reasoning is I have to read a lot of text for being a lawyer or being a jurist, and the aim was to enable the computer to read the text for me and present the facts he just read in a shorter way, so that I don't have to read all the text. Because like 400 years ago, there were 5 books for biology, chemistry, and physics, and you read them all, and you were a genius. And now you read 5 books about one topic, and you barely scratch the surface.
That's
so there's so much information you need to gather, and I want the computer to help me to gather that information I need to decide an actual facts of the case.
And for this you used natural language processing.
Yes, for that I used methods of natural language
What
processing.
can you explain very shortly what this is, more like?
Now, in a way, it's like you take a scissor with a computer and cut the text into smaller pieces, and then you take a text marker, which is called a tagger, and you mark the words. The basic steps normally is to annotate the word class. So it's a verb, it's an adjective, it's a noun, so that you then can derive conclusions about the text just from, which part of language this word belongs to.
Okay, great. And this is called NLP in a short form, right?
Yeah, NLP is the overall term for doing all that.
Okay, and can this NLP help computers understand legal text? Can it be applied to legal text?
Yes, it can.
Okay. And how?
it's a bit tricky because legal text has its own special features, but it's legal text is not natural language anymore, in my opinion. But it's a facts of the case orientated language, and it's my aim is kind of to have the possibility to shift that facts of the case grammar to an object orientated grammar, so that you can use it with a computer, and then shift it back to that facts of the case orientated grammar, so that you can serve the normal customer which uses natural language.
Okay. Meng, you chose a different approach.
Yeah.
You came up with a new programming language for legal contracts. Can you explain very shortly how this works?
Yeah, I think just like you guys, when I was reading contracts, I got very tired. And it reminded me of when I was driving late at night on a long drive, I would get very tired. And I think everybody can understand how it feels to be driving and driving and driving, and you almost fall asleep. And that's not just a problem for normal people, it's also a problem for professional drivers, right? Taxi drivers. I've been in taxis where the guy was clearly falling asleep and I didn't feel very safe. And this is an era where the self-driving car is going to happen soon, right? And when cars can drive themselves, I won't have to drive, the taxi drivers won't have to drive. And this is the same idea behind having a programming language for law. If it's possible for a machine to understand these contracts, to read them, if it's possible for a machine to write them, then we don't have to pay these expensive lawyers to do things that they also sometimes fall asleep doing, right? It's tiring for us and it's tiring for the lawyers too. And so having a language is the first step towards being able to let machines do some of the work that we used to have to do in our heads.
And the approach you choose, can you give some words on that?
Yeah, so our approach is we're trying to be pretty general. We're trying to cover all kinds of different legal contracts. So financial contracts, investment contracts, but also employment contracts, service contracts, maybe real estate conveyancing, maybe maritime. There are many different genres of contracts in different industries. And our goals are to, first of all, provide security so that you can't have a bug in a contract. Those are very bad. We've seen with the DAO that bugs can be incredibly expensive.
Okay, I need to buzz. Sorry.
Buzzword.
What is take the Buzz Lightyear.
Yes.
What is the DAO?
So the DAO, a decentralized autonomous organization, this was something that happened when Ethereum, do I need to explain Ethereum?
No.
Okay, so Ethereum came around and very quickly people built this thing called the DAO and they wanted to use it to fund projects. But there turned out to be a bug in the DAO. And very quickly somebody exploited this bug and used it to take a lot of money out of the system. And to fix this, they had to centralize a decentralized currency and make a central decision to intervene and fix the bug.
Very good.
All right.
I think Buzz got it.
All right. And so in future, it should be possible to avoid these kinds of bugs by having a programming language that is a little bit more secure, where the compiler does a little bit more of the work, and the whole thing is based on better technology and better math to prevent these things from happening in the first place.
So can I just
go?
Do you really think that a compiled language is the way to go, and not an interpreted one?
Well, it's kind of a matter of degree. We want to build a high-level language which expresses your intent, but also gives you enough flexibility to express any customizations and configurations that you want to add. So what will it compile to? So once you write the high-level language, you should be able to compile 10 lines of code into 10 pages of PDFs.
Okay.
Or into Ethereum as well. So it could turn into English or German or Ethereum. Those are some of the goals. And those are goals that we share with Lexus.
Do you disagree?
No, it's just that I needed more information to understand what he's really doing and trying to do.
So
I just met him.
It's the difference between natural language processing and natural language generation, right? And so you're starting with natural language and you're trying to extract meaning from it.
Yes.
And we're starting with the meaning and we're trying to produce natural language from it.
Okay. I think this is a good way to stop in here and show you a little clip of, which we did with a company called Lexus. And I want to have you watch it and give some words on it.
Dear Society Hackers, today we present to you Lexus, making law computable.
Welcome to the second edition of Code in the Future. We're here in Berlin in the Alte Münze. This used to be a coin minting factory. I'm here with Henning Diedrich. Hi Henning.
Hi Alice.
Henning, you're the co-founder of Lexus and you basically developed a new language for lawyers and developers. How do the two things come together? Why do we need to have a common language for lawyers and developers?
So we have this new thing of blockchain smart contracts. And that is something where developers now can do something that actually moves money, that actually has consequences, and is something that's very hard to stop once it's set in motion. Very often what's happening right now is not really covered by advice from lawyers. So we are developing a language that makes it possible for lawyers and programmers to talk with each other in a more efficient way.
What exactly are smart contracts?
Where basically a contract that is designed like a program can now, using the blockchain, transfer real money.
Okay, and these contracts are developed by developers, not by lawyers. And what you want to do with your language is introduce lawyers to the field of smart contracts so that they can like intervene or have a look on what's happening there.
Right, it's not like lawyers are not part of the picture now, but the communication between those two worlds is really hard.
Because they speak two different languages?
They speak two different languages, they use the same terms, it's even worse, I mean they use the same words and they mean something completely different.
Okay, so let's do the next step. Show me what you came up with.
A lot of business that's actually happening right now on the blockchain is crowdfunding.
Crowdfunding,
Yes,
okay.
and so this is how this looks in the moment. It's basically something that is a very widespread language, JavaScript if you want, and Ethereum it's called Solidity. Specifically, this is a certain moment in the crowd fund when all the funds are collected and the payout could happen. And all this can be automated with blockchain smart contracts.
What exactly does it say for non-developers?
So, and this is exactly where Lexon comes in, where you can now write this like this, which is much closer to real English. Basically, this type of text is fed into the Lexon program, Lexon compiler behind the scene. And what comes out is, on the one hand, exactly what we have over there, smart contract code and is used for Ethereum. And on the other hand, what comes out is legal text, which is like plain English, plain German, but so that a lawyer and a judge can work with that. And this basically, this dual output that is created by the tools that we're actually creating, coming from this, is what allows to bridge this divide between lawyers and developers.
Okay, so taking the case that in the future lawyers and developers will communicate better, what are we, the users, going to see from that?
What can happen is that new markets can spring up that in the moment don't have a chance because you can just not afford to police them if something goes wrong. And that opens the door to something beyond that, which is machine-to-machine business, where you can have now business between your washer and your TV. This is the science fiction basically that will make it possible that all this can happen, and not only happen but also according to the letters of the law and the spirit of the law, which is otherwise a problem where big companies are not going to go because they are not going to program anything or make devices intelligent that in the end could open them up for class lawsuits when something goes wrong.
Okay, Meng, how is the approach of Lexon different from what you do, and how do you evaluate what you just heard?
So I like Lexon because it's starting from a very well-defined domain, and it's a very hot domain. Ethereum and smart contracts are getting a lot of attention, and a lot of lawyers want to understand what's happening with blockchain, and they can't really read the code right now. And so it helps a lot when you've got this bridge between the two worlds, which connects the new world of Ethereum with the old worlds of law. And if they're successful, there'll be a new language which lawyers can read and which developers can write. Maybe they can both read and write, and they can understand each other. So I think that's very helpful because it upgrades the language solidity. Right now is very JavaScript. It's very technical, it has a lot of punctuation, and a lawyer reading it might be turned off by how technical it looks. But a simple programming language, whatever the language is, if then else statements are if then else statements. And if we can turn it into something that's a bit more human friendly, something that's closer to AppleScript, then I think the lawyers will find it much more approachable. Lawyers are definitely smart enough to understand a program, because a contract really is a program. It's just written in natural language instead of a formal language.
Okay, and how is it different? What is exactly the difference to what you do?
So what we're doing is we're going a little bit broader than Ethereum, and that may be a strength or it may turn out to be a weakness. We want to cover other kinds of contracts that are not on the blockchain. And we think of these as smart contracts nonetheless, because imagine if blockchain and Ethereum and Bitcoin did not exist, right? It's possible to talk about smart cars and smart cities and smart washing machines. It's possible to talk about smart contracts in the same way. These are computer-enabled contracts that computers can understand, but they don't necessarily have to be automatically transacted on the blockchain.
Okay.
So that's what we're doing. We're thinking about smart contracts starting off as code and then turning into English or German.
This is very different from what you do, right?
Yeah, it's very different because you have to rewrite the whole domain, kind of, because when you start from the meaning, then you have a definition set of rules and you have to rewrite everything by these rules. But my approach is kind of, I look at the actual used rules, the actual language, and try to bring them to a more formal way so that you can then agree on something. But it's not, then you don't have to rewrite the whole thing from the semantic point of view, but you kind of get into it. And it's in my point of view, a different but more successful way in the ending, because you don't have to rewrite everything. When you want to leave your domain for the next one, you have to bring all the words in back together. But when you have a machine that understands normal language, it's very easy. It's easier to get into a new domain.
Okay, I see. And do you think the two approaches can be combined in a way?
Probably, yes.
The question goes to you.
Absolutely. I mean, one of the goals eventually is to be able to round trip between natural and formal language, so that when we write something, we can pass it to him, and then he reads something and he can pass it back to us. And the ideal contract should be able to survive that trip.
Yeah. So between prosa and the object-oriented representation of your contract, there has to be a way from one end to the other and one back, and that shouldn't lose any meaning at all.
Okay, so we have been discussed like really on a very technical level here, and this question I'm with all the time, and maybe it goes to all three of you, but maybe Florian, you can start. Do lawyers now have to learn programming or not?
Yes.
So the funny thing is, lawyers are already programmers, it's just nobody told them.
Okay.
So it's really about awakening this hidden power in every lawyer's brain, which is they are good at language and they are good at logic. And that's all you need in order to be a good programmer.
Okay.
Doesn't make you a good computer scientist necessarily, that needs some mathematical skills, which lawyers usually lack. But it's really enough to be able to write smart contracts and to program in the language that will potentially come out of legalese. And I think lawyers are very uniquely suited to do this. What is needed now is actually for the educational system to catch up with the reality today, which is already when lawyers graduate from universities, if they completely stayed away from acquiring technical skills, they already have a significant disadvantage at finding a job than the lawyers that have tech skills. That's a very real thing already. So the incentives are there, and there are a lot of young people that voluntarily, like here on the hackathon, full of students that are so motivated to learn coding. Now the universities really have to provide the educational framework for this to become a mainstream feature of lawyers, I think.
Okay.
Yeah, I agree. I think the new generation of law students who will be in school tomorrow are people who grew up learning JavaScript on their own anyway, so they're not afraid of technology in a way that maybe the older generation were, right? Yes. And I look at a lot of people who are lawyers. Some of my best friends are lawyers, and I just think to myself, you could have been a programmer if you just made some better life choices.
And how is it looking like from the computer scientist side? Are we also going to see like a movement on the developer side towards law or legal tech? Is there a tendency? The developers just discover this field for themselves and say, oh, maybe there's something I can work in?
I don't think it's that they discover it for themselves, but the law people come to them and tell them, oh, we have a need, and then they will serve them as they serve us other customers and try to model a system for them that is helping them doing their job better.
I think a new field that we will see is the so-called legal engineer. And the legal engineer is someone who has legal knowledge and technical knowledge. And that person can come from either side.
Yeah,
it's like in patent law, where you have patent lawyers that either studied mathematics or physics and then made this extra education, or they studied law and made some extra education. Sorry, Kristall.
No, it's no problem, but there's a term called knowledge engineering, which says that you try to bring knowledge from a certain domain to an AI. So, and that's kind of what's happening here. We have to rework the legal system in a way that an AI will be able to understand it in a way.
Okay.
And that's our goal. So then the AI can help us understand us better.
Yeah, I think programmers inside banks have been doing automated financial legal transactions for a long time. And now with blockchain, we're opening the door to programmers outside banks also playing in the same kind of playground.
And the legal engineers are going to do the same as you just described with the banks,
Yeah.
but outside or inside the law firms, or both?
Oh well, yeah, they could be anywhere. And I think another set of people that you should mention are the entrepreneurs, which are now discovering law as a new market to disrupt, as they love to say, right? It's an industry that is ripe to be Turinged, they say, so
That's
being
right.
disrupted by the computational principles.
I think we should buzz the Turing.
What does it mean for an industry to be Turing?
Okay, dear Buzz, for a field to be Turing, it means that the fundamental principles of computation and digital technologies move from the fringe to the very core of the field. Everything becomes based on computation and connectedness.
Did Buzz
That
understand this?
would be my definition, but I think it's open for debate.
Or, in other words, as Mark Andreessen used to say, software is eating the world, and so software is eating law.
Yeah.
Now, I think there's an interesting point which you mentioned, which is that entrepreneurs are discovering legal tech as a ripe domain to be disrupted. But I think before they discovered it as a domain that they could operate in, they first discovered it as a pain point. And every entrepreneur that I've known, by the time they get to their first financing, they are sick of looking at contracts as a layperson.
Yeah.
And they realize that the work that a lawyer does conceptually is no more complex than the work that a programmer does, right? Programmers think about incredibly complicated abstractions all the time. They think about what if this happens? What if that happens? How do I change my code so that I prevent this problem? That's exactly the sort of thing that lawyers think about. And yet, lawyers get paid $600 an hour to do this. And programmers sort of have to figure it out for themselves. And so that is going to change, right? We're going to bring the methods of our industry, which could be anything from languages to compilers to GitHub and collaboration tools. All of these things are coming to the legal industry, just as a way of solving the pain point that we originally faced.
Great, I have to stop you here because we're running out of time. It was very interesting. I'm actually very curious about the future. There's a lot to come up, I think, on both sides, developers, lawyers, and also customers like me. And thank you very much for being here, and enjoy the rest of the hackathon.
Thank you.
Cool.
Got it.
Thank you guys.
Yes, thank you.
was the second edition of our Hacking Society podcast. We hope you enjoyed it. If you like what we do, subscribe to our channel, give us a thumbs up, and please leave some feedback in the comment section or send us an email. See you the next time.